So deformation of a body due to force acting on it. So let us consider a body of length L, and we are going to apply uniform tensile force of P kilonewtons. So as we are going to apply tensile force, the body tends to change its direction. The body tends to change its direction, and there is a deformation in the body. So this dashed lines or dotted lines refers to the change in dimensions or change in length of the body. So this distance is called as delta L. So this delta L is the deformation of the body due to application or action of force acting on it. So let P is equal to tensile force in kilonewtons. Let sigma be the stress induced in this body. Epsilon naught is equal to strain in this body, where L is the length of the body. E is equal to modulus of elasticity or Young's modulus. Modulus of elasticity or Young's modulus, and delta L is equal to deformation of the body. So delta L is the deformation of the body. So as we are going to apply uniform tensile load, what happens? Some stress is induced in the body. So stress, as we know, stress is equal to simple formula, that is load acting per unit area. So let us assume as equation 1. So the next step, what happens? Strain. So what is strain? Change in length by original length, or change in dimension by original dimension. So let us assume as equation 2. We know what is Young's modulus or elasticity, modulus of elasticity. E is equal to stress divided by strain. So let us assume it as equation 3. So we are going to get 3 equations. Equation 1, that is stress, equation 2 strain, equation 3 modulus of elasticity. Please don't get confused. This is capital E and this is epsilon naught. This is strain, this is stress, and this is modulus of elasticity. So now I am going to put this equation 1 and equation 2 in equation 3. So we are going to put or assume equation 1 and equation 2. We are going to put this equation 1 and equation 2 in equation 3, that is in modulus of elasticity. In equation 3, as we know, modulus of elasticity is equal to stress divided by strain. From equation 1 we know that. So what is stress here? From equation 1, P divided by A, that is load acting per unit area. So P divided by A, that is load acting per unit area, whole divided by. So what is strain here? Strain is nothing but change in length by original length. So change in length by original length. See, now let us see what happens here. Let us see what happens. I am going to erase this part. So P by A into L by delta L is equal to E, which means E is equal to PL by A delta L. But what is delta L here? That is deformation of the body. So we are going to cross multiply. So delta L is equal to PL by A into E. So this is a formula in order to find the deformation of the body when force acting on it. So what is the formula? Delta L is equal to P into L divided by A into E. So what is P? Load. Load which is acting on the body. L. So what is L? Length of the body. A. What is A? Area of the body. E. And modulus of elasticity of the body. So from basic equation, that is 1 and 2, that is stress and strain, after assuming these values or after putting these values in equation 3, we are going to get the formula, that is deformation of the body due to force acting on it. So let us calculate some numerical problem based upon this deformation of the body. So now let us calculate some numerical problems. A steel rod of length 1 meter long and 20 into 20 mm dimensions in a cross-sectional area which is subjected to a tensile force of 40 kilonewtons. Determine the elongation of the rod when modulus of elasticity of the material is equal to 200 GPa, that is gigapascal. So what is the elongation? That is delta L. So what is, let us find the elongation of the body. So what is the first step? Given data. So what is given in the question? As we know, length of the body is given, that is 1 meter, and all the units are in mm. So 1 into 10 power 3 mm. Next, cross sectional area, that is A is equal to directly 20 into 20 mm. Next, which is subjected to a tensile force of 40 kilonewtons. P is equal to how much? 40 into 10 power 3 newtons, because kilonewtons, in order to convert kilonewtons into newtons, we have to multiply with 10 power 3. And E is given as 200 GPa, again 200 into 10 power 3 Newton per mm square, or mm square. As we know, this is a body of length 1 into 10 power 3 mm and cross sectional area of 20 into 20 mm, right? So what is the formula in order to derive elongation of the body? That is, we know delta L is equal to P into L by AE. So this is the formula for finding the elongation of the rod. So what is P? P is nothing but force or load, that is 40 into 10 power 3. So let me write here. So 40 into 10 power 3 into L, length, into 1 into 10 power 3, because we have converted into mm, right, divided by A. So what is the area here? Cross sectional area, 20 into 20. 20 into 20 is multiplied with E, that is modulus of elasticity, 200 into 10 power 3. So let us check the answer. Delta L is equal to, let's check the answer. So 40 into 10 power 3 into 1 into 10 power 3 divided by 20 into 20 into 200 into 10 power 3, that is 1.2. So 0.5 mm. So 0.5 mm. So what is given in the question? Length, a cross sectional area, along with tensile force and modulus of elasticity is given. So what we need to find here? We need to find the elongation of the body. So what is the first step? Given data. What is the second step? You have written the formula, that is elongation of the body, that is delta L is equal to P into L by AE. You have substituted these values and you have found the answer. So what is the elongation? It is very small unit, right? That is 0.5 mm is the elongation of the body. So this body is elongated up to, for example, this is a body of length 1 into 10 power 3 mm, right? After application of load of 40 kilonewtons, it has elongated how much? 0.5 mm. So this is elongation. Example 2. A hollow cylinder of 2 meters long and 50 mm outer dia and 30 mm inside dia. If carrying a load of 25 kilonewtons, find the stress in the cylinder and also determine the elongation of the cylinder when modulus of elasticity is 100 GPa. So in this question, stress is not given. We need to find stress and then we need to find the elongation of the body or deformation of the body. In previous problem, directly stress is given, but first let us write the given data. So what is given in the question? First one, length, that is 2 meters. So let us convert into mm, 10 power 3 mm. Outside dia, that is D suffix O is 50 mm. Inside dia, that is denoted as D suffix I, that is 30 mm. Next, load P is given, that is 25 kilonewtons, right? Yes, 25 into 10 power 3 newtons. Next, E, elongation, modulus of velocity or Young's modulus, that is 100 into 10 power 3. So now let us find the stress induced in the cylinder. Stress in the cylinder. Right? So what is the formula for that? Stress is equal to simply load acting per unit area. As it is a halo section, right? Halo. This is the outside dia, that is 50 mm, and inside dia, that is 30 mm. Right? So what is load given in the question? That is 25 into 10 power 3. So 25 into 10 power 3 divided by area of the halo section. So what is the area of the circle? Simply pi by 4 d squared. Since we are having two circles here, means halo section, so area differs. So formula also differs, right? So what is the formula for this? Pi by 4 times of outer dia DO, that is outer dia square minus inner dia square. Simply pi by 4 times of, what is outer diameter? 50 mm. So 50 square minus 30 square. What is 30 square here? Inside diameter. So we are going to get the stress. Let us find the stress. So I am going to divide 25, that is load, divided by 10 power 3 by pi by 4 times of outside diameter, that is 50 square mm minus 30 square mm. So answer is 19.89 Newton per mm square. 19.89 Newton per mm square. This is the stress which is induced in the cylinder. Now we are going to find the elongation. That is delta L is equal to PL by A. So what is P here? We know that is load. That is 25 into 10 power 3 times of L, length. That is 2 meters. That is 2 into 10 power 3 area. So we need to assume both the areas. So what is the area here? Pi by 4 times of 50 square minus 30 square. 50 square minus 30 square times of E. What is E here? Elasticity. That is 100 into 10 power 3. So delta L is equal to again 25 into 10 power 3 into 2 into 10 power 3 pi by 4 times of 50 square minus 30 square into 100 into 10 power 3. So approximately we are going to get 0.39. Approximately we can assume as 0.4 mm. So 0.4 mm is the elongation of the body, whereas 19.89 is the stress induced in the cylinder.